Okay, I'm going to start this video by explaining a joke, and I promise it's relevant. This is the first context that I saw linear operators in. Linear operators are pretty weird, but this joke motivated it for me, so hopefully it helps you a little bit too. So here it is. A differential operator and a function meet in a street. Okay, so already this is weird. I don't necessarily know what a differential operator is. I maybe know what a function is. And the function says, I'm not afraid of you. I am e to the x. Why is this funny? Because you can take the derivative of e to the x and it's still e to the x. So maybe a differential operator is maybe something that takes a derivative. The function e to the x is not afraid. And the differential operator says, well, too bad for you because I'm d by dy. Okay, let's look at this. All right, so it appears from the joke that maybe some allowable differential operators are d by dx and d by dy. And what do? They take something like y equals e to the x, and these are equal, so you can apply it to either side. And we're just going to apply the differential operator. Well, d by dx, let's apply it to the right so that we know how to differentiate. This is the same notation as derivative of e to the x by dx. And that's e to the x. So e to the x was not afraid of this one. Well, what about d by dy? We're going to apply it to the left. It's equal. So if we applied it to the right, we'd just sub in the left. And this is dy by dy, which is the derivative of y with respect to y is 1. So we've changed the function. So I don't know, maybe functions are afraid of being changed. Not quite sure in the context of the joke. However, these are differential operators. And these are actually, these ones are linear. What does linear mean? Linear means if I put in like d by dx, if I put in a function, let's say e to the x, let's also put in sine x, let's put in x squared. And if I put in maybe even coefficients, like 3 and a 4 here, this is the same as e to the x plus 3, d by dx. We're going to apply the differential operator, and we can kind of distribute it to each function and pull constants out. So we don't care about constants, and we don't care about addition or subtraction. That's what linear means. Okay, why do we care? Well, we were looking a couple videos ago at this differential equation, y double prime minus 8y prime plus 15y equals 0. And this is actually, we can think of a differential equation as a linear operator. Y double prime, this is the second derivative with respect to x, right? Minus 8 dy by dx plus 15y equals 0. So if we are allowed to write things like d by dx with no function here, then we can actually factor out a y on the right. So this is d2 by dx squared, the second derivative with respect to x. That's the operator. Minus 8 d by dx plus 15, the constant, and then a y over here. And we say that if we distribute the y, we end up back up here. That's this notation. And now this whole thing is a linear differential operator. So we can call this L. L is d2 by dx squared, minus 8 d by dx plus 15. And so we can write this as Ly equals 0. Why do we care? Because we had our previous equations, our previous solutions. Remember we did a guess and check, and we got y equals e to the 3t and y equals e to the 5t. And let's just call this y1 and y2. Then I know that ly1 equals 0, and I know that ly2 equals 0 because I started with guessing e to the rt, and I solved for r and got 2 values. But the differential operator is linear, so that means L of a y1 plus b y2 is going to be a times L of y1 plus b times L of y2, and each of these is 0, so this is also going to equal 0. So there's another way of thinking about why this combined solution, a e to the 3t plus b e to the 5t, is a solution after we know that these two specific ones are solutions. And that's thinking about this as a linear operator. Let me also just give you an example. So like this is certainly a linear operator. I'm going to write this one up here. d2 by dx squared. So I can do whatever I want. I can add operators together, multiply by things. Here's one that's not linear. Would be something like d by dx squared. What does that mean? If I applied that d by dx squared to e to the x, believe that means we do this twice and multiply them. So that would be e to the x times e to the x is e to the 2x. And that is a perfectly fine differential operator. Not useful in this class. We're only going to be dealing with linear ones. But I just wanted to give you an example so that you would see why it was important to state that this was linear.